Hello, this is Jack Hooper. This is my presentation that I did on the evidence of hydrogen deuterium exchange within metal adducted carbohydrates after ion-ion dissociation reactions. This is by Jack Hooper, if you didn't know that, but yeah. Just some background information of the analytical technique that we're going to be getting into and how it got advanced in this research. So tandem mass spectrometry is used in fragmentation and becoming one of the most effective methods for mass spec. It gained sequence and structural information on a lot of biomolecules that become important in today's world. So this research investigates ion-ion reactions where either proton transfer or electron transfer can occur from interactions between multiply charged cations and singly charged anions. We'll get more into that later, but as you can see off to the right, you have a little example here where this will be your the mass determinant, like the biggest fragment, which is the M plus peak and such like that. And the molecule that is responsible for most of the catalyst reactions that are done in this research is fluoroethane. It is it has a selectivity that causes electron transfer dissociation and minimizes proton transfer when interacting with peptides. And that is this molecule off to the right here. Cool little molecule made of carbons and hydrogens, and we'll see how it comes into play later. So, the study investigates the dissociation mechanism of ion-ion reactions between fluoroethane and metal adducted carbohydrates. The four metal ions that are talked about in this presentation, or this research for that matter, are calcium, magnesium, cobalt, and nickel, all in the +2 oxidation state. Just a little continuation. The hypothesis that was proposed in this research is that specific physical properties of metal charge carriers correlate to fragments formed and the extent of hydrogen deuterium exchange, or the HDX for a little abbreviation. The main goal of this research is differentiating isometric carbohydrates using ion-ion reactions to induce fragmentation for mass spectrometry. So, if you don't know what isometric carbohydrates are, that is this over here, to the right, top right, and it talks mainly about how, like, isomer of a sugar or a carbohydrate, for that matter, the rearrangement of certain molecules on a given carbon chain will change the carbohydrate, or the monosaccharide, if you will. And the main carbohydrate that is tackled in this research is called melistitose, if I'm pronouncing that right. It's a very complex 3-ring carbohydrate, and the research is going to see if they can replace some of the hydrogens on some of the branches to see if fragmentation of the reaction with fluoroethane works. So, the analytical method, if you haven't heard, mass spectrometry, it will be using that in this research. So, just like I said before, deuterium labeling is used on the carbohydrates to observe evidence of hydrogen deuterium exchange occurring after ion-ion dissociation reactions. The researchers proposed electron transfer dissociation and proton transfer dissociation, and the intermolecular proton transfer, and that's also can be referred to as hydrogen deuterium exchange. So these mechanisms to explain the deuterium labeling data. So yeah, as shown off to the right, that's exactly what is getting into. So there's going to be multiple experiments of this, and we'll see the results soon enough. But the materials included are the melistitose, the cobalt chloride, nickel chloride, methanol, deuterated methanol, and nanopure water. I'll tell you why cobalt and nickel are mainly mentioned here because further discovery is made on that. And the nanopure water was mainly to clean the containers used for these experiments and to make sure that they are clean as ever. And the methanol and deuterated methanol will be used to initiate the melistitose to have either deuterium or be hydrogen surrounded, in a sense, to have all branches be surrounded with deuterium or hydrogen. So, as I was said, the melistitose was mixed with each metal salt at a molar ratio, as shown, in 25 micromolars to 50 micromolars, and either in protonated or deuterated methanol. And it is stored like that for around 24 hours, up to 24 hours at 0 degrees Celsius. So, as to the specific type of mass spec that is used, or mass spec machine, is the Orbitrap Fusion Tribrid mass spec. And it does ion-ion reactions, and they were all performed with fluoroethane as the anion reagent. Experiments were run to examine whether hydrogen-deuterium exchange could occur from interactions with fluoroethane, and fragments were identified manually by computing theoretical mass and charge values with the assistance of the glow workbench and ChemDraw, two applications that are used in this research. So the results. You find that metal ions influence fragment fermentation. So the ion-ion spectra to the right here is of doubly charged fragments found for every metal adducted to melistitose. It is labeled as such with A, B, C, and D. We have the labeling to the left here if need be. And so the precursor of natural loss fragments are labeled in black, gallistic bond cleavages are labeled in blue, and cross-ring or internal cleavages are labeled in red. And so you can see all those fragmentations along the curves, and you can see due to drastic changes amongst all the four is that more fragments were detected with cobalt and nickel compared to calcium and magnesium. So that's why earlier there was mainly a use of cobalt and nickel instead of calcium and magnesium, because they found that metal ions influence fragment formation. And then continuing on, so with research, the results is that hydrogen deuterium exchange is metal charge carrier dependent. So we have another index for you to go along with all the mass specs that are provided. And so what we can gather from this is that the most intense precursor peaks are associated with the nickel 58 and 24 magnesium isotopes that are fragmented off in this mass spec. The high mass accuracy of the Orbitrap fusion was able to selectively monitor the fragments resulting only from the fully deuterated precursors. So that was greatly important. And another result found of all this is that the data showed a distribution of the fragments having between 1 and 7 mostly. And so deuteriums at a reaction time of 50 milliseconds, with most intense peak occurring at 4 deuteriums. That is shown in mass spec F. So, yes. all good information. And lastly, because of all the mass spec run, it was put into effort as to proposed mechanisms for the given mass specs. And the proposed mechanisms were made for the first one, ETD, and then the second one, PTD, and lastly, hydrogen deuterium exchange. Or yes, sorry, I talked in abbreviations. Hopefully you got that. But the chemical mechanisms for ETD, PTD, and intermolecular PT or HXD are independent of the metal ion to produce a specific cleavage, though the metal ion properties affect the likelihood of ETD, PTD, and HXD for a given fragment. So in all these proposed mechanisms, as I stated earlier, that the given catalyst would play a part of these, and you can see in some of them that it leaves with deuterium, and that is very important, very drastic, because it can show that this research has worked and that the mass specs indicate that deuterium exchange, hydrogen deuterium exchange was made possible and was initiated properly and succeeded. So, conclusions. Research shows that deuterium labeling can effectively be used for mechanistic analysis of ion-ion reactions between metal-adducted carbohydrates and fluoroethane research. Also concludes formation of charge-reduced fragments is dependent on the metal carrier, with cobalt and nickel, as I said earlier, forming the significant numbers, and that hydrogen deuterium exchange observed for metal-adducted carbohydrate fragments after the initial ion dissociation reaction with fluoroethane, which is distinct from previous data examining protein peptides. So, all this research is for the effort of better being able to characterize foreign classes of biomolecules, in this instance carbohydrates, but hopefully in the future this can be applied to even proteins and fats and likely just said all three big macronutrients. And so, yeah, as the conclusion, here's the publicated work that was used, and thank you very much. If you have any questions, I don't know how to answer them via a recording, but I hope that they get answered. Thank you very much.